Okay, let's talk about, sorry, talk about electrolytes and non-electrolytes. Electrolytes. Generally speaking, an electrolyte would be anything that dissolves in water and conducts electricity. Okay? You have strong and you have weak electrolytes, but an electrolyte dissolves in water and conducts electricity. So non-electrolytes, do they conduct electricity? No. Okay? They may dissolve in water, like sugar dissolves in water, but just because it dissolves in water doesn't mean it conducts electricity. So that's really all that we're really getting to look at or think about today. So at each station you have 4 different stations, and I'll explain how that works out in a minute. You're basically just taking a solution. We have a little meter that measures how much electricity it conducts. You'll stick that solution in there, you'll write down the number, and then you'll later on sit back down and compare those numbers. The conductivity size, the value that you get, basically depends on how well that solution conducts electricity. So the more electricity it conducts, the higher that number is going to be, that value. Okay? Strong electrolytes produce large numbers of ions which result in high conductivity values. So in order for something to conduct electricity, it has to dissolve in water, and it's going to have to split into its ions. If it doesn't split into its ions, it's not going to conduct electricity. That's how it works. So we'll have to kind of keep an eye on that. Weak electrolytes have low conductivity values, and of course we just said non-electrolytes result in no. Um, the difference between strong and weak electrolytes, strong electrolytes, 100% of them split up, all of them, no matter how much you're putting in there, they all split up. Weak electrolytes, there's like only 5% of them split up. So you have a few of them that split up and conduct electricity, but not enough to make it very strong. So those are the kind of things that they're going to want you to think about on the back when you get there. So we basically have 3 different sections, or 3 different types of compounds. You have ionic compounds. That's going to be your group A. So if you want to look on your data table that you have, right there, group A, you might want to label those. Those are your ionic compounds. Okay, just giving you a heads up. Maybe that'll help you answer some of the questions. They're ionic. They're strong electrolytes because they 100%, all of them split up. Okay, and they give you an example here. They show you how they split up. They split up into their ions. We've done that before. It might have been a while, but we've done that before. I'm going to jump down to acids and bases. Acids and bases, okay, they can either partially or completely dissociate. Okay, a strong electrolyte splits apart completely, so it has high conductivity values. Weak electrolytes, or weak acids and bases, only partially split up, so they have low conductivity values. So you have you have strong acids, you have weak acids. You have strong bases, you have weak bases. Hydrochloric acid is a strong acid. Okay, the pH on it is going to be really low. We'll get into that later on. But vinegar, acetic acid, is a weak acid. So vinegar is weak. It's still an acid. Only some of them split apart, so that's why it's a weak acid. But it still conducts electricity. I'll have to look and see. I've done it a couple times. I haven't done it in a few years. Did you ever see a glowing pickle? Anybody see that before? You basically can stick 2 nails into like a big dill pickle and then plug it into, well, you try not to plug it into the wall, but you have something that can generate electricity, and the electricity will flow through that, and the pickle will start to glow a little bit. You can't really eat the pickle afterwards. It kind of dries it all out and everything, but you can basically make a pickle light up, and I'll see if I can find a little video on that. Okay, I don't want to ruin a perfectly good pickle, but so weak likes do conduct electricity. Okay, and that's all we're doing today. Oh, sorry. And then the third, that group, the acids and bases, are your group B. Okay, so you might want to write that down. Group B is your acids and bases. I'm just trying to give you some hints so as you go through and answer the questions, you can kind of figure your way through this. And then group C is your molecular compounds. Molecular compounds, right? They don't have ions. They don't split into their ions, so they don't conduct electricity. So that would be your group C on the data table. Those are molecular compounds. Water is a molecular compound. Water does not conduct electricity. Pure water does not conduct electricity. I have distilled water back there. You'll see that. The conductivity value on it is really, really, really low. That's probably just some impurities or something like that. Now, tap water, the water that comes out of the sink, conducts electricity. But what do we have dissolved in your drinking water? What's in it? It's not pure water, is it? Okay, what else is in there? Nobody knows. What do they put in there for your teeth? Okay, so you have fluorine. What do they put in there to kill bacteria? Alcohol, no. Better not be. Y'all be drinking. You be drinking all kinds of water. Same thing you put in for swimming pools. Yeah, chlorine, right? Chlorine's in there to keep the bacteria. Nobody wants any bacteria growing in your drinking water. And especially in San Antonio, the reason you have to leave all that little white scale behind. What else do we have? It comes from the aquifer. Starts with an M. Minerals. Okay. So you do have things dissolved in there in tap water. So tap water conducts electricity. Not real well, but it does conduct a little electricity, and you'll see that also. Okay, so on your lab, I'm going to try to help you out here a little bit. I'll explain in a minute how you do this, but you're going to go along. You're going to gather the data for your data tables down here, and then you're going to split this. You're going to flip this over, and you're going to, again, you should be able to fill in that data table from what we just talked about and what we said. You should be able to answer question 2 if you read through the front part. Okay, that's why this is given to you. A lot of your answers are right in that first page. But you need to show these splitting apart. And they gave you an example right here. All you're doing is writing them down and splitting them into their ions. So CaCl2. What is it? What ions does it split into? Thank you. Ca, which has a +2 charge. And how many chlorines? 2. That's what they want you to write. They want you to show how it splits up. And I'm telling you now, and later on, you'll see the more particles it splits into, the higher the conductivity. The more particles that can carry that electricity across the stream. So this has 3 particles to it. Okay, this one is going to split into 4. This one's going to split into 2. So this should have the least amount of conductivity. This one should have the highest. This one should be in the middle. Okay, those are all our group A's. In group B, question number 4, write the equation for the dissociation, just like we did up here. So all of these, I'm going to help you out. That's where they're going to split between the Na and the O when they dissociate. Acids are written so that they drop the first H. That's where they're going to split. This one splits into the 2 polyatomic ions, and this one splits right there. Another hint for you, and you'll see it as you go along, This is a strong base. Can you see it up there? Yeah. This is a weak acid. This is a weak base. And this is a strong acid. So I have them separated out so it'll help you out a little bit as you go along. So I'm going to draw one of these. It tells you over here in the instructions, if it's strong, you just draw one arrow. If it's weak, you draw a double-headed arrow. I just told you that this acetic acid, your vinegar, is a weak acid. So if it's weak, I'm going to write a double-headed arrow, and I'm going to split it into its ions, H plus and C2H3O2. If it's strong, I would use the normal arrow. If it's weak, I'm going to use the double-headed arrow. So you're really just going to finish filling this out. Number 5, we already talked about. You should be able to do that when you're done gathering